Hello and welcome back. It's time once again to try to fix something, and today on the workbench, a PS4, our old friend, the CUH-1215A. And this particular one, I believe, is no power. Yeah, we are plugged up back here. We are no power. We're totally dead. So, power supply issue or mainboard issue? I'm thinking most likely power supply issue because we don't have standby power. So let's get into this and see what the problem is. I did forget to mention that the security tape was gone from the screws on the back, so somebody had definitely been into it, and you can kind of tell the way that Blu-ray cable is twisted around. But yeah, we're not the first ones in here, and I am wondering if they've already tried a power supply. Have they ripped the 4-pin? Still seems to be attached to something. Let me get the supply out and see what other surprises await us. Alright, supply is out, and this thing was really clean looking, and to be clean it does still have a few residents. No longer living, but there's roaches. I don't see a lot of residue, the usual corrosion and stuff you see, but yeah, there's definitely something going on there. So I'm going to guess roaches have killed our power supply. You know, it's not like that never happens or anything. Let me get my spare supply in there and see if that brings it back to life. Well, our spare supply is installed, and we're ready to see if we've got any signs of life now. How about the eject button? No. Nothing when I press the eject button. I know that's a good supply. I know I have AC power in. We've got a mainboard problem. Something possibly shorting down one of the power rails, one of the standby power rails. Because there's like a 3.3, a 1.1, a 1.8, possibly also a 1.998 or 2 volts, we'll call it. So something has shorted something out, I think, because that's very unusual on this model. All right, it is what it is. Let's get the covers off, and I'll tell you what I'll do. I'll flip it back over, and let's just confirm that our 5 volts is actually coming up and is not being shorted out. So let me do that. All right, I got my multimeter set up here, ready to go. Getting a ground down here in this USB port. Do we have our 5 volt standby? Right about there. We do have it, 4.88. So our 5 volts, our 4.88 standby is not being shorted out. It's after that point. And we do have our power good signal. Yes, 4.84. The power good signal is there. So it goes power good. This is the on-off command over here. This would be ground, and this would be 5 volt standby. So that all looks normal. Still no signs of life, huh? No. Alright. Mainboard's got to come out. Well, as I start to take these covers off and to get down to the motherboard, we're seeing more and more signs of roach corrosion going on the board, or on the chassis I should say. Haven't seen the board yet, but so yeah, it looked clean on the outside plastic covers, but not so much once you start digging. And the hard drive screw is missing. Yeah, I have not taken that out yet. Okay, that's odd. Alright, well, I've got the main board out here, and I don't see any horrible corrosion. There's definitely something going on up in here, this area, and you can see there was more residents in there, but I've never seen roaches be able to short out the board here, because 12 volts is like the highest voltage on here. They short out the power supply all the time because there's several hundred volts. If they step across it, it arcs, and that's the end of it. But so So yeah, not sure if this is actually, roach damage, or just the roaches were already there and then something else got it. Maybe lightning, who knows. So, well, get it inside on the workbench after I clean it off a little, and let's see what we can find. We are inside at the workbench, and I was going to do a little quick check by applying power to this board. I've got my little harness here where you bring in your 5-volt standby, and I've got my ground clip. And I want to show you what it's doing when I connect this. Watch the current draw. We're set for 4.8 volts, and if I get this plugged in, we're plugged in 7 milliamps, and that's it. It doesn't do anything else. Normally it would be just draw about 25 milliamps and then shoot up to close to 300 and come back down, and this whole sequence it does. It's not doing any of that, which kind of implies a dead south bridge, or at the very least a south bridge that doesn't have something it needs to run. So yeah, here's our south bridge, and this is our regulator here for the generates a lot of the standby voltages. The RT, what is it, 5069, best I can remember, if I can zoom in. Yeah, so I don't see any shorts around that though. Nothing's shorted. I do need to check, see if those supplies are coming up though. I know it generates a 3.3, a 1.1, I want to say a 1.8. Can't remember all the different rails it makes. But anyway, something weird's going on with this one. Should be interesting. Alright, so we're drawing 7 milliamps and we're missing several voltages. We're only getting 4.4 in there into this RT5069. We are not getting 3.3 out, or the 1.2, 1.1. We are getting, there's like a 1.9 over here. I see that one. But several voltages are missing. And our supply voltage seems to be down to 4.4, which I'm not even sure if that chip will run at 4.4. It normally gets about 4.8. So that's interesting though, although we're only drawing 7 milliamps of current. So there's not much chance of seeing any heat. It's not like there's a dead short or anything. But I'm not exactly sure how the path of how the 4.8 gets here, but I've never seen it that low, 4.4. So, all right, that didn't take long to find. I think I've located our switch, our MOSFET. Let me show you right here. This IC right here. Let me get this kind of turned somewhat right. This side of, you see these vias right here. If I put a probe in here, and let's roll over here to the, there's some corrosion on the capacitor right there. I gotta take care of that. But this is where that standby voltage comes in at this pin right here. And it's right here. So I'm saying this is where our 4.8 standby comes in to this switch right there. And this other side right here, I put a probe in here. I'm in continuity mode. If I come down here, these two coils, like here, and there's another one down there at the bottom, right there. Those are connected to that other side of the switch. So this is our RT5069, which looks like it has a hole in it. Doesn't have a hole in it, does it? No, that rubbed right off. That is what switches the power to our RT5069 to make our standby voltages. This. I'm not sure what controls it, but that's what does it. That's a digital transistor there. I recognize that number on it. So obviously this is an in, this is the out, this has got to be the gate. Now, is there something going on with this? Is it just not being told to go on fully? Because we do have some corrosion going on up there around the up here where the standby voltage comes in. You can see that there. See a little bit here. But this is related to the Blu-ray drive, so I don't think that's our issue. It does need to be addressed, but that's going to keep the... these are the buffers for the switches inside the Blu-ray drive. Those 3 little micro switches you may have seen inside one. Those are buffered by these 3 digital transistors right there. But anyway, that looks a little yucky. But like I say, I'm not reading a short. You know, I'm getting the full 4.8 right here. It's just once it gets switched by this, it's only down to 4.4. But we're only drawing 7 milliamps of current. So that doesn't seem to add up. So let me see what I can figure out. Let me do some measurements around this area. Maybe make comparisons to another board and see if we can figure something out here. All right. Are we making any progress? Well, maybe. I've been trying to figure out, you know, where this, how the 4.8 gets switched to that other IC down here. And this is the control for it here. I compare it to a working board, and in a working board, this sets about 1.5 volts into the control port. I think this is the gate of this MOSFET. And when that's the case, then you've got a nice short between here and here, and you get your full voltage across there. But we're not having that. And I can tell you, this is the digital transistor. So what should normally happen is you have a high here, turns on this is the gate, turns it on, it conducts, and then you conduct voltage from here through here. It's a divider. And I think this is a 200K, this is a 100K. You get about 1.5 volts there, and everybody's happy. But in this case, the 3.3 is not here. There's nothing there. And so I've been trying to figure out, where does this come from? Is it something from the south bridge? Is it something from the system controller, you know, way down here, this IC? Doesn't seem to come down here. At least it doesn't come straight there anyway, because I can't find, you know, in continuity mode, I don't find it. But then I went to, let me flip the board over, went to looking around the south bridge area, thinking, well, it's either the south bridge or that system controller that would be sending that signal to it, I think. So I'm looking around under here, and I don't, you know, see any corrosion or anything, nothing obvious. And I'm looking around, and oh, what's this? What's this? Missing components. Get them both in the shot. This, somebody did this when they were handling it rough, I guess. This is a resistor. I don't know the value yet. This is a capacitor. I think it's just a bypass capacitor. This one is probably not critical. This one very well could be. So let me look at another board. I'll just flip over to it and move this one out of the way. This is a working board here. We're going to look at that same area right there. Yep, you can see a resistor and a capacitor. If I can get everything in the shot. Yeah. Now let's see what the value of that resistor is. Can I get a reading? Can I get a reading? Why can't I get a reading? Oh, I'm in continuity mode. That's why. Let's get back into resistance mode. Now we can get a reading, I bet you. 40 k ohms. That way, I turn my probes around. 46 k ohms. And let me try, move the microscope out of the way. Let me try these tweezers I got. Just got these in. These things are supposed to be pretty good at checking stuff in circuit because of, you know, they use a low test voltage. So what if I go into, can I get into resistance mode? Let's see if we can get across it in a way that you can see it. Whether we can both see it. Come on, get on there. Did I read that wrong? It says 4.574 k ohms. I thought I read something much higher than that earlier on my other meter. 4.3 k ohms. Not sure how well that's showing up. 4.3 k ohms. It's probably a 4.7 k ohm resistor. I mean, it's just a common value, used in logic stuff. But let me check it again with this meter. That says 46 k ohms. Okay, I'm very confused now. Okay, tell you what we're going to do. We're going to flip that resistor around, and we're going to find out what value it is exactly and stop guessing. Okay. Let me switch back to the microscope a second so I can see what I'm doing. Right about there. Let's just spin this thing around if we could. I don't necessarily want to take it off. I just want it spun around and isolated. Please let go. I have to turn my heat up. I'm at 385 or something. I probably should just add a little bit of leaded solder to one end or the other or both. All right. I don't want to destroy it. I like to be a bit kinder and gentler. Let's just add a little bit of solder, leaded solder to it. And that should help it be more willing to comply. Then we'll have to let it cool off a little. There we go. All right, now we're spun around. And we're out of focus. Okay. What do we have now? Oh, that board's hot. 46 k ohms. So it's a 47 k ohm resistor. Okay. I come up with one of those. Let's see if that helps us with our missing supply rails on the other board. Alright, we've replaced that 47 k ohm resistor that was missing. Does that make any difference with our symptoms? Okay, I'm going to be watching the current. Oh yeah, 23 milliamps. Up to 127, 28, back down to 95, 31. All right, we're working. Here, I'll get you a shot of it so you can enjoy the wondrous joy that it is, like I am. All right, so yeah, you can see our supply is hooked up. Let me unhook it right here, and I will show you my bench supply when I plug in the 4-pin now. That looks good. And shoot up to something more than 100 and back down. Yep, that looks good. I got a feeling our rails are going to be there. Let's just hit the power button and see if she tries to turn on. She does. All right, we got lucky on that one. I will replace that capacitor. Small bypass capacitors like that aren't usually critical because there are tons of them all over the board on the same rail, but I'll replace it. But yeah, I think we're ready to take this back out and put it in the chassis and see if she is doing more than it was earlier. We are back out in the garage, and I think at the point of testing, I did, I had a resistor to change out that had been knocked off, and there was a capacitor that had been knocked off. I didn't know the value of it. I did lift that on the good board inside and checked it, and it was a, no surprise, 100 nanofarad, 0.1 microfarad, whatever you want to call it. So a standard, bypass capacitor. I had those on hand and replaced that. And let's see, I did some cleanup while I had it, while I had it apart. I went ahead and cleaned up the cases to get rid of the, roach remains. So it's a lot cleaner than it was, and I think she's ready to turn on. I have everything hooked back up. I put the original supply back in it because I did a quick check of it, and it showed having +5 standby. I don't know if it puts out +12 or not, but the standby supply was working in it. So yeah, there's my test one over there. So I'm hoping that's a good supply, and that the whole problem was that knocked off component. So our monitor is on. We have power. What's going to happen? Blue light. Fan is spinning. All good things. I saw the monitor lock. There we are. We have a logo. No white light yet, but we are coming up, I believe. I don't remember if I brought it up without the hard drive or not, because it seems to take forever if you do that. Yeah, we're rebooting. The fan has stopped spinning. Come on. The hard drive is accessing. That fan is not spinning. The blue light is... Oh, there's the fan. I've never seen it stop that long. The hard drive is clicking away. Oh, there's a white light. Okay, so I guess we have a bad hard drive. Could not start PS4. Okay, that's not surprising. Everything else has gone wrong with this one. But I think after a hard drive, we'll be in good shape. So that, surprisingly enough, was a relatively simple one. But I kind of got lucky, just looking around on the back of the board and finding that knocked off component. I really wasn't expecting that. But I hope that was somewhat interesting or educational, enjoyable in some way. If it was, please give me a thumbs up, and I will see you in the very next repair. So long for now.